right, so we're going to start with section 6.6, and this is a review what we did in class, but I thought I would go over these questions that we talked about. So we talked about this during the quizzy review that we did, that we know that 3 to the third power is 27, but how do we justify that we actually know that? So here's what you're going to do. You have your log card. So I'm going to keep this up here. Actually, we're going to this side, right? To this side, okay? So let's see. When I write a log, my base is, oh, that's right, it's 3. The X always goes to the opposite side, and the 27 piece goes there. Now, once you have that, all you need to do now is work on your calculator. If you go to your math button down here on A, you can plug in a 3 and a 27 and get the answer of 3. I like to keep my X on that side, but if that really bothers you, it's not a big deal. Okay, so why would you learn how to do that? Well, quite honestly, what do you do if you get something that doesn't work out nice and neat? Such as we did in class, 5x, 5 to what power is 95. Now, we did talk about in class that 5 to the second was 25 and 5 to the third was 125. Okay, so it's got to be between 2 and 3, but probably closer to this. Well, let's go and write it as a log. So this would be log. Here's my base, 5. My exponent goes across and I get a 95. So on my calculator, I'm going to do log. Whoops, I'm gonna hit math. I'm gonna go down to A, and I'm gonna hit 5, and I'm gonna put 95 here. And I end up with 2.83 because I'm going to round that 9 up that 2 because 9 is above 5. Okay, so as far as those pieces go, that's really what we're looking at here. So I want to do this one. 7 to the 9x equals 15. So the minute you throw in something, remember, you don't need to lose what you've been looking at, okay? So the big question is this a base to a power, just like these were here? Yes, this is a base to a power. This is a base to a power. This is isolated. So at this point, now I can flip it to my log. So here we go, log 7. The power always goes across the equal sign. And what haven't I used? The 15. Now, this is going to be really important on when you're using your calculator. You can also do change of base, by the way. You can do log 15 divided by log 7, and you'll get the same answer as if you did math and go down here, but I tend not to use. I find this a little cumbersome having to go there, but you get the same thing. Now, don't get rid of that on your calculator, okay? You can write it down if you want. Oops, how about I write it down the right number? Did I write it down right? Oh yeah, 1.39 equals 9x. How do I get rid of that 9? You're right, divide by 9. So divide by 9. And if you didn't get rid of it on your calculator, it's pretty nice. You didn't round at all. So that is the most accurate answer that you can get. So awesome job on that. Okay, the next one we tackled here was 4e to the negative 0.3x minus 7 equals 13. Okay, so let me ask you this. I know there's an e, but it's still a number to a power. This is all the power. Sorry, I didn't write it up in the power. That's all the power. So this is what I want to solve for. So I need to get rid of this 4 out front. Okay. So what is 13 divided by 4? That's 3.5. So now I have e to the negative 0.3x minus 7 equals 3.25. Okay. Now I have my base to my power. I can go from this to this, except I'm not going to use log because e is with what number on my calculator? Right, the ln. So the nice thing about ln is you don't have to worry about your base. That's your base. Where does my power go to? Well, on the other side, like it always has been. And 3.25 goes here. On my calculator, you don't have to use the math button because you can just push ln 3.25 and hit enter. Now, don't round, okay? Like you could, if you wanted to, just to write it down here, but I'm going to do the whole thing and get an accurate number on my calculator. All right, tell me what I can do with this 7. You're right, add 7, okay? Okay. And now divide by negative 0.3. Divide by negative 0.3. And I get negative 27.26. And see, you didn't round until you got into the very end, and you didn't even have to really worry about it until the end. All right. 2 quick ones. 2 concepts that we finished up with today, really before we left. ln 4x minus 7 equals ln x plus 5. And we talked about if you have ln's on both sides and you were to raise these both to the same, they're really quite equal to one another. So we can actually just ignore the ln's and just solve for the variables. So 4x minus 7 equals x plus 5. I'm going to subtract x. I'm going to add 7. I get 3x is equal to 12, so x is 4. You want to make sure when you plug 4 back in that you get positive numbers. Otherwise, our answer could be extraneous. The last one, I'm going to do a sticky note, but we did this and then the bell rang. The last one we did in this section was log 2 5x minus 17 equals 3. Excuse me. All right. Now, notice I gave you a log, right? Here to here. All right, are you ready? All right, so notice that the log, the 3 pieces to the log are there. 3 pieces. 1, 2. Chewy, excuse me. Okay, so 2 to the 3rd power is equal to 5x minus 17. Well, friends, you can totally do that. 2 to the 3rd is 8. Add 17. I get 25 equals 5x. Divide by 5. Divide by 5. X is 5. Make sure, if you were to plug that in, do you get a positive number there? You do. Just because I can see that 5 times 5 is 25, that's going to give me a positive number. Okay, now, I want to take this a step farther, okay? I'm going to take this a step further. What do I do with something like this? Okay. What do I do with something like this? Well, you see how there's 2 logs. I can't just cancel them out because this doesn't have a log either. It's different than the ln problem that you had. So you have to go back and remember the section where a plus really means what? So here's your choices. Is this really mean a product? Is this division? Or does this mean an exponent? Well, a plus is, drum roll, it's a product. So that means I need to rewrite this as log 2x times x minus 5. So remember, this is condensing. Well, log, so what's 2x times x? 2x squared. 2x times 5 is 10x equals 2. And then you might say, okay, well, that's great. Now what? Well, I need to go from here to this. But what's my base? Oh, that's right. I forgot my base is 10, though I don't see it. All right, so here we go. 10 to the second power equals 2x squared minus 10x. What's 10 squared? That's 100 equals 2x squared minus 10x. There's a squared. I'm thinking I'm going to have to factor this. I better get everything equal to 100 or equal to 0. Anything in common I can get out? Oh, yeah. I totally could divide everything by 2, couldn't I? Well, that just gives me 0. X squared. Now I don't have to worry about the cold Brooklyn method. And what is that, 50? All right, here we go. One's a plus, one's a minus. Factors of 50. That subtract to give you 5. How about 10 and 5? But my answer really isn't a positive 5. It's really a negative 5. It's not really a negative 10. It's a positive 10. Now, if you take a trip with me up here, do both of these work? So let me write with a highlighter. Does a negative 5 work in here? Or a negative 5 work in here? Ugh, no way. That's going to give me log of a negative 10. If you're not sure if that actually works, let me show you. Log of a negative 10. And you get non-real answer. That's right, because you can't get that. How about a 10 though? Oh, a 10's going to give me positive. 10 is good. So we would say that this one is extraneous. Okay. So be on the lookout for those multiplication where you can take the product back together or separate them. We'll work on some more problems tomorrow.